Welcome to the Lippis Report.
Hi, I'm Nick Lippis from the Lippis Report, and I'm here at Ixia's ISIM City to test Cisco's flagship Catalyst 6500 Enterprise Ethernet switch to stress all the new features and performance improvements of its latest massive upgrade with the Supervisor Engine 2T. In these sets of tests, we actually look at access control lists, which are important tools in the configuration and customization of network attributes, especially with the Catalyst 6500. In the Cat 6500 upgrade with Sup2T, the TCAM has both been increased and its architecture improved. For ACL, one major concern was the lack of visibility of overflowing the TCAM when new ACL scripts were submitted, which would disrupt network operation. Updating ACLs occur infrequently and over a long period of time. As such, multiple network engineers working on the same network may not even be aware of the previous ACL updates. Further, an ACL update may drive multiple ACE entries, which occupy more TCAM resources than anticipated and thus, over time, consume this resource. Therefore, Cisco developed the ACL Dry-Run and ACL Atomic-commit to mitigate this scenario from occurring. We demonstrate this new efficient use of TCAM and ACL safeguards. Hi everyone, I'm here with Divya Rao, who's the Technical Marketing Engineer at Cisco. Say hello, Divya.
Hi everyone.
Great. Well, what we're going to be doing now is the ACL test. So we're going to really stress the TCAM in the new Catalyst 6500. And the way we're going to do that is that Divya has spent a lot of time writing a very large 50,000 line ACL. And we're going then to basically upload it to the Catalyst 6500. And we're going to see if we basically are going to go through a dry run to see if there's enough TCAM in order for the 6500 to load all of those programs or all those lines of code. And then after we see what it has to tell us, whether we can go forward or not, then we're going to maybe make some modifications and then go to finally what's called the ACL Atomic-commit. So that's what we're about to do. Okay? All right. Sound good?
Sounds good.
Great. So just to also let you all know, we're in the ISIM City control room. So this laptop is now connected to the 6500. So Divya, first, let's take a look at the ACL that we're going to load into the 6500.
Sure. So this is the file here.
Yeah.
It's opened up as a text file, and all it is an extended access list, which is 50,000 lines long. It's just a bunch of permit statements, and it goes all the way from line 1 to line 50,000. Okay,
yeah, that's a very large list. Now normally, a network engineer wouldn't create such a large list to upload to a Catalyst 6500. So we're just doing this to really kind of stress the TCAM.
Right. We're just going to see how big of an access list can fit in the TCAM on a Sup2T.
Great, excellent. All right, so then let's upload it. Okay.
Sure. So I have the access list saved on the compact flash disk 0.
Okay.
And that's where it is. So what I'm going to do is copy this file over to our current running config.
Okay.
Now since the access list is 50,000 lines long and we have to pass through the entire file, this copy operation is going to take about 2 to 3 minutes.
Okay, great. So we're going to shut off for a little bit and come back in a few minutes. Okay? Thanks, everyone.
All right, so the access list just got copied over into the compact flash on the supervisor. Okay. And we're going to apply the access list onto an interface and watch how it gets programmed into the TCAM.
Very good. Excellent.
So as you see here, the TCAM programming is just at 1% for each of the modules on the switch.
Okay. And that's right now, so that's without uploading the new file.
Right. So I'm going to apply it on interface 10 gig 1/1 and look at the programming again. It still hasn't been applied because the interface is shut down. Yep. As soon as I enable the interface, the access list is now going to be pushed into hardware.
Okay, great. Yeah, well, there's a difference.
There's a difference. So you can see it's at 39%, and the increase in TCAM capacity on the Sup2T is fourfold compared to the Sup720. So a size this big of an access list would have completely blown out the Sup720.
Oh, I see.
And
Okay.
what this means is if the access list cannot fit into hardware, any entries that do not fit get programmed into software. So this drives the CPU high. And we have no way of telling if it's going to blow up the TCAM or if it's going to fit into the TCAM before applying it. Now on the Sup2T, we not only have an increase in the capacity of the TCAM, it's also shared between different resources. The same TCAM is used for QoS and access list, and it's more flexible in how you can allocate the TCAM. And we have what we'll see next, dry-run capability, where we can check the programming in TCAM, verify if it will fit before actually applying it.
Great, yeah. And so when you do overflow the TCAM, and part of it's in software, part of it's in hardware, obviously the CPU utilization goes way up, but also do you get network disruption?
Yeah, definitely with CPU disruption. It depends on how many of the packets are being software switched. If you have a significantly large number of them and your CPU is at 99%, you could drop control packets, you could see the keep alives being dropped, and you could see some disruption.
Okay, so very important to do a dry run.
Very critical, yes.
Great.
So what I'm going to do next is get into the dry run config mode to modify this access list, and then we'll validate the config before actually applying it.
Okay, great.
So this gets us into dry run config mode. I have a few lines that I'm going to add to the access list to verify if it will fit.
Okay. So what is it doing right now?
So right now we are getting into the access list config mode, the dry run config mode for this specific access list. So if we want to add or modify any statements, we can do it here.
Oh, okay.
And then validate that before actually applying it.
Very good.
Alright, so we're now in dry run config mode, and I'm going to add a few lines to this access list. So this is just going to test the programming in TCAM without actually applying those config lines.
Very good. Okay.
So I just added 4 new lines, and I can go look at my dry run session. Okay, so now we're going to get back into dry run config mode and validate the config to make sure it's going to apply in TCAM. We have a command that is show config session test session status, and it says the config will fit in TCAM.
Okay,
so then we can apply it.
Excellent. Yeah, so result equals config will fit in TCAM. Excellent.
Right.
Very
And
good.
if the config does not fit in TCAM, we just back out everything and don't program it at all.
Okay, very good. So we're ready to commit.
Exactly.
Very good. Hi everyone, welcome back. So we're ready now to do the ACL Atomic-commit. But before we do that, a couple of key things that we've set up. One is that we have real-time monitoring of the Catalyst 6500 back-to-back. So we have 8 Ether channel 10 gigabit Ethernet links between the two, and we're monitoring that traffic. It's running at 100% throughput right now. Now the reason why we want to show this in real time is that in the previous generation of the 6500, whenever we did an ACL update, there would be a slight loss of traffic, so you get actually a hit in traffic. Now what we're going to demonstrate with the ACL Atomic-commit is that there's not going to be any hit, no degradation of performance whatsoever on the 6500. So previously we showed that we can update the ACL without overrunning the TCAM. So we know that we're not going to have any difficulty there. Now we're ready to basically upload the entire ACL and commit it to the 6500 and have it operational. Anything you want to add to that, Divya?
Right, so before we get started, we'll just go ahead and bounce one of the member ports in the Ether channel and monitor the traffic. So we should see a slight blip in the traffic on the screen on the right.
Great. So one of the 8, we're going to basically bump them, and so we should see a blip here.
Right.
Okay. So we're going to be down here. So you can see as soon as Divya hit the shut, a little bit of delay, but now all of a sudden the utilization drops down. It just shows that we're in real time, so we shut down one of the 10 gigabit Ethernet link channels. Okay?
All right, so I've re-enabled it, and in a moment we should see the traffic pick up again to
Okay.
100%. And in the meantime, I can show you the access list that we're going to modify. This is the same large ACL that we were working on yesterday.
Yep.
And it's been applied on port channel 11, which is what we're working on.
Okay, and it looks like the Etherlink channel came back up, so now we're at 100%.
Right.
Okay, great, very good.
So what I'm going to do is get into the access list mode and remove a line of the access list
Okay,
and exit out. So when you hit end is when the access list gets reprogrammed on the interface.
okay. And that's when it starts to upload the ACL list, onto that
Right.
interface. Okay.
So it just took out that line 20, which you can see is missing here. And if we look back at the graph, you can see that there's been a relatively straight line, so
Yeah.
we haven't noticed any hit.
Right, so we didn't get any performance hit
Exactly.
as we committed the ACL. So we did the atomic commit, it's loaded, it's running, and there was no performance hit.
Completely hitless.
Great, and that's what we wanted to show.
Yep.
Hi everyone, Nick Lippis here at ISIM City, and I'm with Divya Rao, who
Hello.
is, great, thank you Divya, who's technical marketing engineer over at Cisco. So what we want to show here is some of the QoS capabilities of the Sup2T and the Catalyst 6500, in particular the control policy. So what we're going to do is essentially almost do a denial of service attack on a 6500 and show the CPU utilization on the Sup2T to get cranked up to around 90% or so. And then what we want to do is then put some policy in place, identify where that traffic is coming from, and be able to throttle down that traffic as it occurs across multiple modules. So not just one module, multiple modules. So right, that's basically what we're going to do, and let's verify that. So,
All right.
Divya,
So
you got
I'm
the
going to
control.
start the stream here that's going to send packets to hit the CPU. And if we tab back over to this window, you should
Yeah.
see that the CPU has shot up to about 60%.
Right, to about 60%. Yeah.
And I have a flexible net flow configured on the control plane interface of the switch,
Okay.
which helps me identify the top talkers. How I've done this is using a flow monitor, which makes use of flexible net flow. And I can look at the statistics with FNF to look at the top talkers hitting the CPU,
Very good.
which in this case is this particular flow that I've just generated.
Okay, yeah, that's right. You can see like the huge packet disparity on that IP address versus the other ones. Yep.
Right.
Great.
So what we're going to do next is configure a QoS policy to throttle down this particular flow. We're going to match on an access list and a class map and police down that flow. And since this traffic is entering across multiple modules through an ether channel, we're going to show that it's making use of distributed policing, which is new to the Sup2T, which means we synchronize the policing rate across all the modules of
All
the
the
system.
modules. That's right. And that's new to the Sup2T. That's not available in the 720.
Exactly.
Right. Great.
So this is an access list that I had pre-configured to match the source and destination IP. And the Sup2T has a control plane policy installed by default. I just added an extra class to it which will police down this traffic. And we can take a look at the CPU again. As you can see, it's now back down to 2%.
Great. Yeah, look at that. So that's great. So, and again, this traffic was going over the ether channels, which we have 8 of them connected between the 6500s.
Yes.
So we're able to effectively just reduce that traffic all across those modules. So, so that's great. Excellent. Very good. Thank you.
Thank you.
Thank you, everyone, and thank you for watching.
That concludes this edition of the Lippis Report. Thank you for joining us. Look for us every Tuesday and Thursday. To get your free subscription to the Lippis Report newsletter, go to www.lippisreport.com. To sponsor the Lippis Report podcast, send email to sales@lippis.com. We've got to go, and so do you. See you next time.